I did a practical quickly. I made my tea just for everybody.
All right, the recording has started. Greetings, ladies and gentlemen. Welcome to Thursday. This is Exploring Industrial Engineering session. Today we'll be covering Learning Unit 4, which is our presenters will definitely let you know what's happening. This is great and exciting, and I hope you did your homework as previously explained yesterday. Kindly please note that to avoid disturbing the presenter, kindly please keep your microphones muted as well as your camera, also to save bandwidth on your side. If you have any questions along or during the presentation, feel free to raise your hand or send them on the chat box, and then we'll certainly attend to it. Without wasting any time, I'll hand over to the professors for the presentation, and enjoy yourselves. Thank you.
Thank you, Tumelo, and good afternoon, everybody. Today we are going to explore Learning Unit 4, which is for Industrial and Systems Engineering in the Fourth Industrial Revolution and beyond. So I'm here with Prof. Ramdas, my colleague, and we'll be going through the slides, and then we can do the questions and answers later. Prof, do you want us to do that assignment first before we go to the presentation, or what?
Yes, so that assignment will be able to for us to reflect on what we've done over the 3 days as well. So we're going to be asking the question why? You know, the 5 whys application. Yes. Now. Firstly, you need to find out why did you make a cup of tea. Okay. On a lighter note.
Because it's cold.
Yes. So there's a reason for everything. Yeah. So let's give. Who are the students here? Is Alpheus the student? There's 2 Alpheus here. Hello?
I suspect it might be the same Alpheus.
Yes, Prof. I'm connected with a laptop and a smartphone.
Okay, so is there only one student here?
It would seem so, but we're doing the recording to add to our content.
Okay, no. The reason I would like many students is that, you know, you get different opinions from different people. So, you know, with one student, you will get one side of the story only. It doesn't allow you to explore other points of view. But anyway, it's fine as it is. Okay, so we're going to continue. So Alpheus, tell me, did you do your cup of tea? Did you basically think about the process, so you can tell us exactly how did you start and how did you end in terms of making that cup of tea? Remember, everything takes time, yeah? So you going, okay, from my point of view, I want to have a cup of tea to basically satisfy my thirst. So that is the reason. So I will go to the jug first and try to make my water hot, yeah? So you're going to start from there and tell us exactly what you've done in your process. Thank you so much.
We can start, Alpheus. Do you want to go for it? Then we can also reflect with colleagues who are here from UNISA also.
Yes, are you referring to me, Prof?
Yes.
Absolutely, yes.
But I have not made any cup of tea, but I can just take you through the process.
But we gave you a special instruction yesterday. So the first thing is that you don't follow instructions. Okay, but doesn't matter. I'm sure you made a cup of tea before. So take us through the steps in making that cup of tea.
Okay, in the first instance, I must have a jug where I go to the tap and get water. After getting water, I went to the kettle. I pour in Then I switch on the kettle, and then I wait for some minutes for the water to boil. As the water is boiling, I'm preparing myself with a cup where I pour in some 2 full teaspoon of sugar, milk, as well as a bag of tea into the cup. Then by then the water will be boiling. Then I pour into the cup. After pouring into the cup, I switch off the kettle on the plug. Then I start stirring for the sugar and the tea to combine to be a nice cup of Joko tea. Then I start drinking. Oh, before that, maybe I start drinking because I've already poured in the milk, the sugar, as well as the bag of Joko. That's how I prepare a cup of tea.
Okay, thank you. So these are some of the pointers that people can note. So you said you went and took a jug. Well, is this your... Yes.
Yes,
on.
come on, bro.
Let me go through and finish. Then we can have a conversation. Yeah.
Yes.
So you said you went and took a jug, and then you took water from the kettle, and then you went and poured the water in your jug kettle to boil, right? So the first point is, why did you take a jug? Why couldn't you take a jug kettle itself? Right, that's number one. Okay, so there's duplication of work there, right?
Yes.
Okay, number two. Now, how much of water did you pour into the jug?
According to the jug.
Normally, people fill up the jug, the jug kettle, for 1 cup of tea. I mean, if you're looking at resources, you do not need to fill it. You put approximately how much you want. So it's approximately 1 cup. Or if you are making a cup of tea for your friend, then you'll approximate and use 2 cup. You'll basically put 2 cups, right? So there's wastage of resources. Number two.
I understand that. Yeah.
Right. Number three. Okay, you said that while the kettle is boiling, you're going to prepare yourself, which is fine. That's 100%. You prepare yourself, but you just mentioned that you're going to use two spoons of sugar. So I want to caution you, when you get to an age like mine, you will take no sugar at all. So you rather start looking at diabetes at the moment and reduce your sugar level to 1 sugar. So basically, if you use 1 sugar, you'll basically, if you buy a 2 kilo packet, that 2 kilo packet, instead of it lasting you 1 month, it will last you 2 months.
Okay.
Are you with me? Right.
Yes, I'm with you.
Now you're going to basically pour your water, your boiling. First, you will switch off your kettle, or the kettle will automatically switch off as soon as it boils. As soon as it's completed, you will basically take that water and put it into your cup where you've already prepared your sugar and your tea and your milk, and you'll basically place it back in its position. And then you will pick up your teaspoon. Where is the teaspoon? Is the teaspoon right next to there? Did you prepare the teaspoon? Did you bring it with your cup? So now you need to think about, when you're preparing, you need all the utensils nearby. So your cup must be you don't put your cups and spoons all in the same place. Yeah? Your cups will be in one section of your drawer. All your teaspoons, your forks and knives will be in another section. So you'll have to walk to the other section and bring your teaspoon, and then use your teaspoon to stir. Can you see the thinking? I'm going into detail here, guys. So when that is completed, then you'll relax it a little bit, so that it can cool down, meaning that you don't get burnt. as
Yes.
well as the tea from the tea bag comes out quite nicely. And while that is happening, you can maybe take out a biscuit or so to have with your cup of tea. So this is analytically thinking about the steps involved, the ergonomics involved, the movement involved in making that cup of tea. I hope that made sense. Thank you so much, Kabo.
Yeah, it makes sense, Prof.
Thank you, Alpheus.
Thank you.
Thank you, Prof. So can we go straight to the presentation, or maybe Dr.
Maybe
House?
we can take one or two questions from Dr. Coase and anybody else before we continue. Thank you.
Yeah, because she has made her own cup of tea, so maybe we can get reflection from her in terms of how she went about it.
Okay, I don't take a jug. I go to the kitchen. I get a tea bag on my way into the kitchen. Then I put it in, pick it off the cup, pick up the cup, put the tea bag in the cup, go to the hydro boil, and I throw in the boiling water and I start drinking. I don't use tea, I don't use milk, and I don't use sugar. Here's my version.
Okay, no, that's pretty simple. No, that's
Yeah.
fine.
Yes, you've got to get to the cup of tea as soon as possible. Yep.
Okay, Chumela?
As for me, I also do it similar to Dr. House. I just get water with the kettle, and then depending on my mood, I can fill the kettle. Sometimes it's just half. And then while the water is boiling, I ensure that I get myself 1 brown sugar of tea, as well as a tea bag. And then in terms of milk, I prefer using liquid milk instead of powdered milk. And while the water is boiling, I think I'll be eating something, or I'll be busy with something. And then that is when I'll start drinking my tea.
Okay, thank you so much. I just want to add to, in terms of what Dr. Coase has mentioned. She said she's got those tanks, you know, where it's like a geyser kind of same situation. So remember now, whenever you want a cup of tea, you want it immediately. However, you need to look at the energy that container is going to take to basically keep water boiling all the time. So that is a wastage of resources from my side. Colleagues, thank you so much.
Thank you, Prof.
Can I add something to that?
Yes, go ahead.
Okay, so I did work out the cost of having a hydro boil, boiling water permanently for me, and I worked out my charge out rate per hour. And so for my wasting time waiting for the kettle to boil, it's cheaper for me to have a hydro boil. But I did do the calculation.
Oh, that is awesome, eh?
Thank you. Thank you. I did take it into account. And when we go away, I do switch off the hydro boil. Yes.
Yeah, no.
There we go. Cool.
No, that is fantastic, because okay, I'm taking my cap as an industrial engineer down, and I'm putting my cap as an environmental engineer. And what you have done is exciting, because you know, a kettle, that element, I think is about 2000 watts. Yeah, I think it's about 2000 watts. That element in the kettle itself. And normally when people make boil water for coffee or tea or whatever, you know, they will not pour exactly for 1 cup. You know, they will pour more. But that is just wasted energy, because you are going to use 1 cup. But you have heated for 2 cups, and you are going to use the 1 cup, and then the other 1 cup will go back to normal temperature, and that heat will be lost to the environment. Then it is just wasted energy and wasted money. So a hydro boil is nice because it's instant. So it's instant heating. So there is no container where you are going to store the water, and after a while it loses temperature like a geyser. because a geyser is just one expensive device that is you don't even see somewhere in the ceiling, and it's costing us, I mean, it's costing people about 45% of your energy bill is from that geyser. So an instant heating system like gas, which works like a hydro boil, it makes perfect sense. You only use it when you need it and the amount that you need, and that's it. You don't have to heat the whole 200 liters and use only 100 liters, and the other 100 liters goes to waste from an energy point of view. So quite interesting that you made that calculation. Okay, thank you. So I will go to the presentation now. Okay, so Industrial and Systems Engineering in the Fourth Industrial Revolution and Beyond. This is Learning Unit 2 by Prof. Ramdas and myself. Agenda is Industrial Revolutions, Industry 4.0, and the critical skill set that are critical in the 21st century. We all know, I'm sure most of you have seen this. This is the progression from 1784 to today. So in 1784, the steam engine was actually discovered, and so mechanization started in terms of steam power, and you can see the steam coal-fired trains started working there, and things like that. So that was steam power that was actually discovered in 1784. Then around 1870, the second industrial revolution started, and this was based on mass production. But this was the important thing here was the discovery of the combustion engine as we know it today. Our cars are running on combustion engine, and this is an old technology. Like it was discovered in 1870, but obviously it has been perfected and improved with years as they went. This allowed mass production, and it allowed formation of assembly lines, and that's where Ford, you can see Ford started around there with their assembly line in the US. And it actually started also the division of labor in terms of people doing this particular skills and a particular job and all that. But the core of the second industrial revolution was the discovery of this combustion engine, which led also to the discovery of electricity. So factories started having electricity, and that's where mass production was possible, rather than during the first industrial revolution, where you are using steam power and you still had a lot of manual labor, but you are using steam to power some of your equipments and things like that. Then we moved to 1969, and that's where the third industrial revolution started. This was that's where computing gained a huge traction with the discovery of microchips, and this assisted or enabled the building of computers, electronic equipments, and that's where automation started. And then the fourth industrial revolution, which we are currently experiencing today, which is CPS, cyber physical systems. And cyber physical system is where there are actually blurry lines between the physical and the cyber, and even biological. I'm sure most of you today are wearing your Apple Watch or your Huawei watch or Samsung watch, or whichever watch that you are, a smartwatch that you are having. The smartwatch is able to record some of the smartwatches. They can record, which is biological now. It can record your blood pressure. It can record your heart rate. It can record your oxygen saturation. And things like that. So from a biological point of view, so now you are having three things, which is physical because you have it here, but it is able to check your biological, I will say, what will be the right word, but your
biological well-being in terms of yeah.
Yeah, but I was looking for like your markers like your blood pressure is a marker, and all those things, and it is able to send information because your watch is synchronized to a computer where you have this app that is running there, and if maybe you are taking a jog, and it can check your heart rate, and it will tell you whether you have gone above the maximum heart rate that you must go into. So if maybe you have, I don't know, your heart rate is like 175, then it will beep and say, for your age, maybe that is too high, slow down a bit. We don't want to risk you going to emergency now. So things like that. So it allows us to use information. I know in some countries it is linked to your medical aid and your response, emergency response. If maybe there is no heartbeat or it doesn't see something for so many minutes or so many seconds, it will trigger your app to send SOS, and then emergency can come and check maybe someone is unconscious or something. So there's that blurry lines between the physical, the biological, and the cyber side. So they are merging into one. And you have Internet of Things where you have smart. You can imagine today how many smart devices are connected to the internet. Now it is no longer computers. It's computers, it's smartphones, it is tablets, it's your watch. So you've got billions of these smart devices that are collecting data every second. And and I think we'll talk about it in the other slides, one of the challenges or the work that is cut out for industrial and systems engineers is how do you monetize data, making sure that you are able to use data effectively and efficiently, and be able to, if it is in the private sector, to be able to maximize profit. If it is in the public sector, how to use data to be able to serve society better. And as I said, if governments can really understand the crucial discipline of industrial and systems engineering, they can actually reap a lot of benefits. Characteristics of the fourth industrial revolution. These are the characteristics that are different. If you look at the first, second, and third, most of them, or all of them, were linear. So they were going through a nice linear, incremental, continuous improvement type of structure. But when it comes to the fourth industrial revolution, things are different. It differs with other revolutions because of velocity. You can see technology is just changing quite quickly at high speed, the scope and the system impact. And the speed of the current breakthroughs has no historical precedent and evolving at an exponential rather than a linear pace. Hence, it follows more of an exponential growth rather than a linear growth, which is more step by step. The other one is more disruptive. It is disruptive almost to every industry in every country, unlike the other revolutions. It is disruptive in the sense that it is forcing companies or communities or governments to do things differently, because some of the business models that were going for hundreds of years have been disrupted and they are no longer relevant today. And I think we spoke about the skills that in 2030, there are certain jobs that will be obsolete. And how do we train a new generation of workers to make sure that they are able to meet the demand in 2030? But also, how do we reskill the current generation that are currently in the job market or in the job working in various companies or governments or whatever, to make sure that they really are able to cope with the demands of the digital age. The breadth and depth of these changes herald the transformation of the entire systems of production, service, management, and governance. And as I said, it is disrupting each and every industry, even higher education. And COVID has just catalyzed the reaction. It made it quicker because we were moving to this angle, but now we have to move with speed, because if we don't, we will be left behind. And these icons were just a demonstration of speed, disruption, and a digital transformation. What is this CPS? This cyber physical systems. As we said, they are disrupting. So there's the biological system, there is the physical system that we spoke about. Okay, there are social systems, because it is disrupting even how society functions. You can see when we were kids, we used to play like in the streets, with many other kids, doing games or whatever. But now children just are stuck in their rooms and on the cell phone and playing games and things like that. So it's a different generation, and it's disrupting the enterprise systems also. So this is just a quick snapshot of what these cyber physical systems are. So they are from organizational point of view, which is enterprise system, from social system point of view, but from physical system point of view, and from biological system point of view. Nowadays, you know that companies, when people go to hospitals, you sometimes find that you can you find that you can go to a hospital, then the X-rays are quicker, the CAT scans are quicker, and sometimes they even do operations using machines nowadays, where the surgeon is sitting at the corner there, but a robotic arm is operating the person. What is Industry 4.0? As we said, Industry 4.0 is about, there are three priorities there. It is digitalization and integration of vertical and horizontal value chains, digitalization of product and service offerings, digitalization of business models, and customer access. So you don't want to, when you want to pay your bill, you don't want to go to Pick n Pay to go and pay your bill. You can do it on your cell phone now. So that is part of changing business models and customer access. So customers can be able to order. You can order from, is it Checkers, 60 minutes, whatever grocery you want. And these are the technologies that are supporting this for Industry 4.0, be it cloud computing. Most of you come from computing. You all know these things. Mobile devices that we all have, Internet of Things platforms, location detection technologies. You now use your GPS. In the olden days, you had to buy a Garmin, I think. Then you install it in your car, or you have the mobile one, and when you go somewhere, but now you can do it with a phone. So 3D printing, smart sensors, big data analytics, Nowadays, when you do stockbroking, is actually algorithms that are doing the predictions whether to buy or sell. You don't have a stockbroker glued to the stock exchange. Now there are analytical approaches where algorithms are doing everything. 21st century skills, and here we are saying industrial and systems engineers, most of them, if you look at the programs, they are actually taking care of this particular 21st century skills. Without these skills, we are not going to be able to manage. Because currently you need people who can collaborate, working with others is very important. Gone are the days where we should work in silos, because the systems are more integrated, the world is more globalized, everything is interacted. Technology is making everything quicker. Now you don't have to travel all the way to Japan or India to have a meeting. You can do it on Teams now, as we do it now, and have live presentation there. Critical thinker, problem solving. This is the core of industrial and systems engineering, is how do you solve problems. So industrial and systems engineers are not just critical thinkers, but they're also lateral thinkers, but at the same time system thinkers, because you think in systems, you don't think in silos. A communicator, you can see the curriculum of industrial and systems engineering. There is a lot of soft skills like communication, leadership, and also creator. So you need to be creative in all what we do. So you will not be able to be creative and improve systems if you don't imagine. So imagination is very important, but you need to imagine, but also take back the imagination, bring it to reality, so that we're not just dreaming, and come with solutions to problems that are facing society, that are more efficient, that are more effective at the same time. And there's a difference between effective and efficient. Efficiency is when within doing something within a budget, within safety, within time, and so forth. But effectiveness is doing the right thing correctly. You must do the right thing first time, every time, and it all talks to quality. So industrial and system engineers have their work cut out in the 21st century. One of the critical issues that industrial and systems engineers are supposed to do is to turn data to gold. How do we, because we said in our first presentation that industrial and systems engineers, they implement, install, and I think we had our own formula. I think it was I squared, integrated systems of people, equipment, information, which is data, energy, and materials. How do we use data currently to be able to develop and design products that are efficient and effective and are useful to society? The digitalization and integration of horizontal and vertical value chains in organizations, be it in government, in the public sector, be it in the private sector. Digitalization of products and service offerings, including the expansion of existing products and services. And I think we also spoke here about business models and customer access, which provides is more how do we expand the offerings by providing disruptive digital solutions, such as complete data-driven services and integrated platform solutions. You can see Takealot. I mean, their platform is so integrated that they can sell you a soap, or they can sell you what is one of the big things, furniture. So they can sell anything in the same platform. So, and it's data driven. They are able to collect data. as you buy from them, they collect data, they see what the types of things that you like, and they will then appeal to you and say, we have a special on this, because they know you buy more of this kind of things. So that is what they do, which is quite awesome. Thank you for listening. This was the end of the presentation. Professor Ramdas, you want to add?
Yes, Kabo, thank you so much. If you can take me to the slide of the creator, collaborator, and so forth.
Okay.
Thank you so much. So remember that, you know, industrial engineering always works with people. So your people skills has to be good. The reason I'm saying this and I'm smiling and laughing is that, you know, attitude and behavior, quite often industrial engineering is about solving problems. How do you solve a problem? The problem doesn't appear there for you to solve. You've got to be working through someone in order to solve that problem. So your mannerisms, your role in collection of information is critical. So your attitude and behavior has got to be right in terms of making that person on the other side feel as comfortable as possible, so that he can basically open up to you and give you all the information that you require. So, you know, industrial engineering cannot work without that. So your communication skills, which is the third one. I mean, you cannot say, you know, there's a factory worker there that's working on the factory floor. Okay, I'm an industrial engineer. I put on my graduation hat on there, and I go and, you know, look at the other person, look down at the person that's working on the factory floor. It doesn't work like that. The person there will look at you funnily, and he'll tell you, take your things and please go away from here, in a nice way. He can say it in another way as well, but he will tell it to you in a nice way. So your communication skills from your operator level, from the sweeper level, right up to the managing director level, because industrial engineering works with all these people, from your factory floor people right up to your reporting to your managing director to tell him, this is the problem and this is what I'm doing in terms of how I'm going to resolve the problem. In addition to that, your critical thinker. You know, quite often the problem is right in front of you and you cannot see it. And quite often I've been in situations where, you know, I change the situation totally just by critical thinking and common sense application, not to make anybody feel bad, but to get out maximum out of the situation through critical thinking. So your collaboration with the person, your critical thinking skills, your communication skill, your mannerisms has to be correct. And you just can't, you know, implement a new system just like that from the top of your head. You have to have discussions with all the people. You have to have buy-in from people, and so forth and so forth. So and you have to plan this implementation so that it will basically benefit your organization, save your skin in a way as well, and ensure that you are basically optimizing what you are supposed to optimize. So the creator level is critical thinking and application in creating that new method, creating that new product, or whatever it may be, so that it enhances your current situation. So these four variables are very, very important. And remember that we're always dealing with people and every person is different. So you want to be on the right side of people and not on the wrong side. And that's the only way you can win in industrial engineering. Thank you so much, Kabo.
Thank you, Prof, for that. And yeah, I think those four key skills, these are the, if you Google skills of the 21st century, those are the skills that will come up. But these are the skills that are inherent in industrial and systems engineering, because industrial and systems engineers are taught to be good communicators. And as Prof is saying, you need to respect everyone, whether just because you've got a degree doesn't mean you are superior to anyone. So a person who's an operator in the plant, you will treat them as you are equal. You will not look down on them. It is very important, and because these guys, you'll find that I worked for Volkswagen in the Eastern Cape, and I found that the old men who worked in the plant, in the assembly line, they've been doing that work for 20 years. If you sit with them and you say, I'm trying to optimize this thing and I'm looking at this angle and this angle, you'll find that because of your good way of interacting with them, they will tell you, no, but maybe if we do it this way, and if we do it that way, it might work. And because they know they've been doing it for 20 years, they know how to do it best. And sometimes they don't do it because you'll find that at that time, management was not listening to them, or they don't worry about them. But with industrial engineers as the middle men between the top and management there, and the supervisors and the workers, you are able to work better with them. And if you show them respect, they will tell you, no, but if you do it this way. I mean, there was a project that we did. We had to remove 2 of the 5 people, but they were not chasing them out. They were just deploying them elsewhere to say, no, they were saying, no, but this thing can be done by 3 people. If we do this, then you use your time studies and your industrial engineering techniques to validate, and you find that nobody can work, then you implement. Then those guys, they will simply, they simply left and went to the body shop from the paint shop because there was more work there. We didn't have work for them here. So it's important to collaborate with other people, but also to communicate best with other people. They always say that the reason why projects fail is only because of 5 reasons. The first reason is lack of upfront planning. The second one is misalignment of expectations. If we are ensuring that our expectations are the same, then we will not have any misunderstandings. The third is poor communication channels. Once there's poor communication channel problem, then all hell is going to break loose. Then the fourth one is lack of resources. And the fifth one is technical problems. Normally, technical problems are the last. You'll find that if you do the first one correct, upfront planning, and industrial and systems engineers are all about upfront planning. If you do upfront planning, the other 4 will fall because the upfront planning, if you fail with upfront planning, that is the cause. This other 4 will be the effects. But if you solve this first one, the others will not come because everything is lined up. So yeah. So thank you, Prof, for that insight. Are there any questions and comments and from the participants and colleagues from computing? You can just it's a small group, so you can just go for it.
Kabo.
Yes, Kabelo.
During Science Week, we are required to make posters on the basics of science. So I was looking at your presentation, if maybe you can simplify some of the terms into the basic of science for sustainable development, and maybe we create a poster from your presentation on 4IR to be printed.
You say the topic is what? Science for sustainable development?
Basic science for sustainable development, but now
okay.
linking it to 4IR.
Oh, okay, now we'll work on something. We'll send you something.
Okay, that's it.
Any other comment or question?
I think his network there is a bit problematic. I think what we need to do is get together with him to see exactly what he needs so that we are able to help him to achieve that. I see Patricia wants.
Okay, so the National Science Week theme is the basics of science, but linked to 4IR. And I definitely think there's a lot in this presentation that we can use as even poster presentations going forward. And also I do think we need to push the career opportunities where the basic sciences can be linked to the 4IR and going forward. Thank you.
Okay.
Okay.
No, thank you. No, we will work
Awesome.
on something. Basics of science. Is it for sustainable development?
The theme is just basics of science, but it's all linked for
Okay.
sustainability. But then obviously careers, we need to equip our young people. When we leave this planet, they need to be able to thrive. And so we need them to upskill them, that they have the skills to thrive.
Yes. No, definitely. I think the young people need to realize we only have one planet.
Yes.
Because because now I think there was a debate. Was it last year? I don't remember where was that. But people were saying no. But let's prepare to go to Mars. Is it Mars or the Moon? I'm like, but in 20 years you'll stuff up the Moon anyway. So
exactly.
we are not going anywhere. We remain here. Let's solve the problems here. So that because I think the way the way society is consuming is a problem, because we are just consuming like there's no tomorrow. So consuming energy, taking down the rainforest and putting a lot of, I've seen in the Amazon where the Amazon is being destroyed and they are putting ranches for beef. So they're putting a lot of cows and all that. But the problem is that with the cows, the methane is a problem. More cows, meaning more methane, because they take out methane every day, and methane is, if things can tip in the greenhouse gases and we have more, because currently there's more CO2, carbon dioxide. If you can imagine, if there's more methane, this world will blow to pieces. There'll be a nuclear bomb we have never seen before, and which is man-made. We made it ourselves, So it's it's a challenge. Yeah. No. Okay. Thank you. Yeah.
Absolutely.
Good insights. Yeah. We will work on something with Prof. Ramdas.
Thank you. Awesome.
Because sustainability,
Thank you
I'm very passionate about sustainability from an environmental engineering point of view. Yeah. So we can do some stuff there, and we'll share these presentations. I will send all of them to you and to Melo and Kabelo and Miss Sbia.
Thank you. Thank you very much.
What's her name? I always say Miss Sbia.
She's Anzani and her sister's
Anzani. Oh, yeah.
We've got twin sisters.
Oh, they're twin sisters. Okay. Yes, sir.
For Science Week, I don't just want the presentation, but maybe we can have a meeting when we have the grant. Because I want you guys to be the author of that poster. So.
All right, it's fine. We can.
The other departments also doing the poster. So I'm just giving you a heads up that I'll be contacting you during that time.
No, it's fine. We'll do that with Prof. We can organize a meeting. We'll come and meet you and sort it out. Prof.
Awesome.
Okay.
Yes,
Thank
no
you very
problem.
much.
If you can give us an idea, when is it going to be?
National Science Week is the first week of August.
First week. So we only got a month then to play with.
You got not much time. Yeah. Yes.
Yeah.
Okay.
I must run with it now. Yeah.
Yes.
Okay.
Thank you very much.
All right. No, thank you. And I think from us, that was it, unless there are other questions and comments. Yeah.
I hope you enjoyed the presentations from our side.
Thank you. Yes, absolutely. And I think we will generate, as we go along, as we're moving forward, we will also generate more interest in this, because it definitely does address career opportunities and awareness of such a diverse career that you can choose from. Yes. I don't think our learners are truly aware of the amazing things that they can do with a single qualification. Yeah. Yeah,
no, definitely. Yeah. Okay. Yeah. No, thank you. So we'll hand over to I'm not sure, was it Tumelo who opened?
Tumelo. Tumelo's going to close for us.
So
yes.
We'll hand over to you, sir. You can go ahead.
Thank you, Professor Khabo, for the wonderful presentation, and to your fellow prof. To our online participants, thank you so much for being part of today's session. Thank you for taking the time to be part of the session. And for those who are watching the recording, thank you once again also for taking the time to have a look at this recording. If you have any information regarding today's session, please don't hesitate to email us on set@unisa.ac.za. And for those of you who want the recording of this presentation, please note that the presentation will also be available on our MOOC website. If you are not yet registered on the MOOC website, kindly please let us know also on the ISET email address. Once again, thank you so much for this wonderful week that we had of exploring industrial engineering. We've certainly learned a lot and look forward to another events of such kind. Once again, thank you so much and have a lovely Thursday.